हेलो डियर स्टूडेंट्स। कैसे हैं आप सब? आई होप यू ऑल आर डूइंग वेरी गुड एंड यू आर वेल एंड healthy. Welcome to the channel and welcome back to the power system playlist. In this playlist we are discussing the basics of the power systems, and up until now we have discussed so many things so far. We have seen basics of per unit system. We have seen how do we define the base and how do we define uh, the base values, and how do we find the per unit values of any quantity available. We have seen about representation of my power system using single line diagram in very last lecture. We have seen the different components or the symbols we use to demonstrate the different components of power system with the help of single line diagram. We have seen the single line diagrams system itself. uh, we have learned how to draw an impedance diagram from the given single line diagram, and based on that impedance diagram we have also learned how do we draw the reactance diagram based on given impedance diagram. Okay, and from that we have learned to calculate the single per unit representation of a single phase transformer, and we also learned the per unit representation of three phase transformers. Okay, and all these little things, all these little small subtopics leads us towards this conclusion. It leads us towards the per unit impedance diagram of my whole power system. Okay, the whole power system. It seems quite massive when you think about it, but when you distribute it in small little parts, then it seems a bit less complex or easier in a way. Okay, so we did exactly that. We divided the whole process in a number of steps. You will find different number of steps in different books. Some books will tell you to follow only 3 steps, some books will tell you to follow 5 steps, some books will tell you to follow 6 7. Okay, so here I have divided the whole system in 6 steps. But before we jump into the things, um, let me make it very clear that in order to understand these steps, you must have basic knowledge about per unit systems, and you must have knowledge about single line diagram, impedance diagram, and reactance diagram. We have already discussed all these things in previous lectures, so if you have not visited the previous lectures, if you have not seen those lectures, you find the link of that previous videos or previous lectures on the top right corner in the I button, so you can access all those lectures from there. If you have not seen those lectures, please visit those lectures and then come back here to understand this. And if you've already seen those videos, if you're already aware of power per unit values, per unit systems, and single line diagram, reactance diagram, impedance diagram, then you're ready to go here. Okay, so here I'm assuming if you're uh, with me till now, I'm assuming that you have seen those videos. So I'm continuing from the very steps which I have mentioned here. So let's begin with that. The first step is what we do: we select the proper base MVA or base KVA, whatever is suitable for my system, either KVA or MVA. Second step, what do? We divide the whole system in number of sections by given number of transformers. Okay, so what do we do? Sometimes if we have two transformer, we divide the system in 2 plus 1 equal to 3 parts. We have 3 transformer, we divide it in 3 plus 1 equal to 4 parts. Sometimes we divide the system with the number of we divide the system in the number of transformers we are having. So if I'm having 3 transformers, then I will divide my system in 3 parts. Okay, so we do that. After doing that, what do? We pick appropriate kilovolt kV base in one of the sections. Okay, and how do we pick base MVA and KV? I've also discussed that thing in the previous lectures. So if you haven't seen that yet, so those lectures will be helpful. Then the fourth step is to find out the kV base of other sections. Okay, first we choose the appropriate kV base for one of the sections, and in the fourth step we find the kV base of other sections in the ratio of the transformation. Okay, then we come to the fifth step. What do we do in the fifth step? We calculate per unit value of voltages. uh, Not only voltages, we calculate the per unit value of voltages and impedances in every single section which is present over there, and then we connect them uh, as per the given topology we have in single line diagram. And when we connect them as per the topology, we will uh, get the single phase per unit diagram of my power system or whatever system you are dealing with. Okay, so you must have to follow these 6 steps. There are some books we will take 3 steps, but the whole and soul of uh, the whole and soul of the whole procedure is um, this which I have just mentioned to you. Now let's see one of the examples for per unit impedance diagram of my power system. So let's take this power system. As you can see that from this single line diagram, I'm having 3 generators indicated by 1, 2 and 3. You can see this this is my first generator, the second generator, and third generator. Okay, the first generator is connected with load A here, you can see. And then we are having 2 circuit breakers. After the first generator we are having a circuit breaker, then the line for load is getting dragged out, and then we have second circuit breaker. Then we are having the first transformer. uh, this is a transformer with two star windings. Both of the windings are ground connected. Then we have a circuit breaker, then we have a transmission line going on over here, and then this transmission line is connected with the another uh, another circuit breaker. This another circuit breaker is connected with my second transformer. This second transformer, both the transformers are 3 phase transformers. uh, and my second transformer is connected with the star delta topology. On the primary side we are having star, or rather I should say the winding which we have on the left side is connected in the star manner with ground connected with neutral, and on the winding on the right hand side is connected in the delta terminology. Okay, then we are having a circuit breaker, and whole my whole system is getting divided in 3 different parts. uh, these parts are consisting 2 generators and 1 load. Now let's come to the uh, values of my given power system components. Like the first generator is having a rating of 30 MVA. Second generator, which is connected over here, is having 15 MVA, and third generator is having 25 MVA. The kV rating of generator 1 is 10.5. For generator 2 and 3 we are having 6.6, and reactance of all three respectively are 1.6 ohm, 1.2 ohm and 0.56 ohms. Okay, for this transformer, the first 3 phase transformer. By the way, how do you know that this is a 3 phase transformer or single phase transformer? So here you see there it is connected. All 3 phases are connected with star connection, star terminology, right? So can you see the star terminology in single phase? No, you can't, because single phase only have one phase. Okay, so it is star connected. So this is a 3 phase transformer with 15 MVA rating, and it is having the voltage ratio of 33 by 11 kV, and the reactance of this transformer on both of the reactance of this transformer is 15.2 ohm per phase on high voltage side. Now let's come to the second transformer. The second transformer is having uh, again same rating as first in terms of kV MVA. It is having 15 MVA rating. on this ratio of voltage ratio is 33 by 6.2 kV. Here we are having different voltage ratio, and the reactance is 16 ohm per phase on high voltage side. The reactance of transmission line is given as well. The reactance of transmission line is 20.5 ohm per phase. And coming to the nature and rating of load, so the load A, which is connected with first generator, is having 15 megawatt 15 megawatt capacity and 11 kV. These are the ratings of the first load, and it is running with a lagging power factor of zero point 0.9. Load B is having 40 megawatt. The voltage rating is 6.6 kV, and it is running at lagging power factor with 0.85. Okay, so now let's come to let's try to draw the impedance diagram based on that. But okay, let's first draw the impedance diagram, and then we will go through all the 6 steps which we discussed. So let's first draw the impedance diagram. So here you can see we have drawn the impedance diagram based on single line diagram in previous video as well. So I'm going to give you a quick little glimpse about it. We will not take much time here. So again, you can see the first generator connected over here with its resistance and reactance values. Then we are having the load A connected in parallel with generator A. Then we are having transformer, this one, the T1 transformer. Then we are having transmission line. If you remember, we have discussed about two ways to represent the transmission line connection. We are having pi terminology, and then we had T terminology. And in general, I've told you that we use pi terminology. So we are having pi terminology or pi model of connection here. You can see we are having the horizontal component we are having is here we are having reactance and resistance. This is the secondary winding of transformer, this is the primary winding of second transformer, and this is the line reactance. This is line reactance, and we are having this capacitors connected here. Then we are having T2 transformer, its windings. We are having the load B, which is connected in parallel with between transformer and the remaining generators. And then in the last we are having generator 2 and generator 3. If you want to know in detail about the how do we draw impedance diagram based on this the based on single line diagram, please refer the previous video. I have already mentioned the link of the video in the I button, and if you want me to, I will also mention the link of the video in the description as well, so it will be easy for you to reach out and see the video, right? Now let's quickly take the proper base MVA or KVA for all of my system. So let's take base MVA as 30 let's take 30 as base MVA, and let's take 33 as a base KV. So let me write it down first. Okay, so I have mentioned here we are taking the base MVA 30 MVA and base KV as 33 KV. Why? Because the highest value was this in the single line diagram. If you see, the highest MVA value was 30 and highest voltage value was 11. So we are taking base MVA and base KV as that. We are taking then what we are doing, we are dividing our system based on number of transformers we have. So we are taking 3 different parts. So voltage based in circuit G1, circuit G2 and circuit G3. We are taking 3 different parts, and the voltage based on circuit G1 we will be taking it 11 kV. For the G2 we will be taking 6.2, and G3 will be taking 6.3. If you want to know in detail that behind the selection of this base MVA and base KV, so that also we have discussed in one video before that, when we discussed about per unit values in detail. So I will mention the link of that video as well in description. If you have not seen that video, please go through, so it will be easy for you to understand how do we select the base kV. Okay, base kVA, base MVA, any any quantity as base for to calculate per unit values. So this is how we took the values. Then what is our objective over here? The objective is we have to find per unit reactance of these components. Which components? We have to find the per unit reactance of transmission line, we have to find per unit reactance of transformers T1 and T2, and then we have to find the per unit reactance of G1, G2 and G3 generators. Okay, so let's firstly always remember, whenever you are calculating, whenever you are solving such type of numericals which include the impedance calculation of whole power system, what you need to do first you need to select the base MVA, base kV, and then whenever you start the calculation, always start from transmission line itself. Okay, if the actual value of reactance of transmission line is given, so always start from transmission line. It makes your work very easier. Okay, though it is not mandatory to start from transmission line, you can start from anywhere, but it is recommended to start from transmission line. Okay, you will know as you go through the sums, so it will be much easier for you. So let's find the per unit reactance of transmission line first. So if you remember, what was the formula for per unit reactance? The formula of per unit reactance was actual reactance multiplied with base MVA, and then we divide it with the square of the base kV. Okay, so come here and tell me what is the actual reactance of my transmission line. So the actual reactance of my transmission line, see here we are having 20.5 ohm per phase. Okay, 20.5 ohm per phase. So we are taking 20.5, then we are multiplying it with base MVA. What did we took as a base MVA? We took 30 MVA, right? So we will multiply with 30, and then what we are having as base kV, we are having 33. See here, base kV we are having 33. So we are we are taking the square of base kV in denominator, and by doing the calculation, the value I will be getting will be 0.5647. So that will be per unit reactance of my transmission line. After finishing work of transmission line, we will come to transformers. So let's find the per unit reactance of the first transformer. So again the formula will remain same, there will be no change in the formula. We will be multiplying actual reactance with base MVA, and then we will be dividing it with the square of my base kV. So what is the actual reactance of the first transformer? Come here, we are having the actual reactance is 15.2 ohm per phase. Okay, so here you can see 15.2 multiplied with 30, my base MVA, divided by 33 whole square, which is my base kV. Okay, and the value which we are getting is 0.4187. I think it is pretty much clear, right? The actual reactance we took 15.3, base MVA again remains same 30. Base MVA will be 30 and base kV will be 33, right? So except if you are not calculating the part when you have divided your circuit, except for that part, your base kV and base MVA will remain same. Okay, so the base MVA base kV is again same 33 as we saw in previous case. So we are taking 33 square and we are getting 4.4187. After that, what we will be doing, we will be calculating the per unit reactance of transformer T2. The equation will remain same, equation or formula will remain same, actual reactance multiplied with base MVA divided by base kV square. So what actual reactance we are having for T2? Actual reactance for T2 is 16 ohm per phase. So we are taking 16 ohm per phase here, 16 into 30 as my base MVA divided by 33 as my base kV. The 33 square is my base kV, and the value we are getting for per unit reactance of transformer T2 is 0.4408. Okay, now interesting case comes up that you have to find the per unit reactance of all three generator G1, G2 and G3. Okay, Again, there will be no change in the formula will remain same. Actual reactance multiplied with base MVA and divided by the square of base kV. Okay, so that's why I have not mentioned the formula exclusively over here, but I'm pretty much sure that you are very clear about it right till now. So firstly, what is the actual reactance of generator G1? Let's see. The actual reactance was 1.6 ohm. See here, 1.6 ohm was actual reactance of generator G1. So we have mentioned 1.6, and then sorry, it is 1.6 here. Sorry, G1 here. We are having 1.6, multiplying it with base MVA, which was 30. And interesting case, remember I've told you, until and unless you take the until and unless you uh, are considering the circuit which you have divided in a number of sections or number of parts, you have to take base kV of that. So here for generator G1, what base kV did we had? See, generator G1 base kV did we what did we took here? See, we took 11 kV, right? So we'll be multiplying it with 11 square, and we will be getting 0.3967 as per unit reactance of generator G1. Same ways for G2, what was the actual value? Actual value was 1.2 ohm. I'm talking about reactance value, actual reactance 1.2 ohms. So we will be taking 1.2 ohms multiplied with my base MVA. What was my base MVA again? It was nothing but 30. Where did it go? Okay, here, nothing but 30 MVA. So we multiplied it with 30, and then again square of base kV. So in the case of G2, what did we took it? What did we took as a base? We took as a base we took 6.2 kV. See, 6.2 kV. So we will put the square of 6.2 over here, and the value we are getting as the output will be 0.9365. So the per unit reactance of generator G2 will be 0.9365. Now for the per unit reactance of generator G3, if you want to calculate that, you must have to calculate that, right? That's the problem. So what you will do, we will again take the actual value of generator actual value of reactance of generator G3. So let's again come here and check what is the actual value of generator G3's reactance. We are having 0.56. We will be multiplying 0.56 with the base MVA, which is 30 again, and the base KVA which we took for this for the third circuit is, see here, where we took 6.3 kV. So in the denominator we will be taking 6.3 whole square. There is a mistake over here, it should be 6.3. Oh sorry, or we can take the generator G2's value as 6.3 6.2 itself. Okay, why? Because see here we are having same KVs of generator G2 and G3, so we should take same KV values for generator G2 and G3. I mistakenly took 6.3 as KV, so we took 6.2 over here, and we will be multiplying it. We will be taking the square of 6.2 in the denominator, and as a result we will be getting 0.4370. So the value of the per unit reactance of generator G3 will be 0.4370. Now remember, what was the last step? The last step was to collect all these components, and what do? We draw the impedance diagram, reactance diagram of the whole circuit. So let's try to draw that. So firstly we will be having the first generator. What is what we will be drawing the reactance diagram based on the impedance diagram only. If you remember, what do we do in order to draw a reactance diagram from impedance diagram? We remove all the reactances, we remove all the resistances, and we also remove the pi model which we took for the transmission line, and we also represent the transformer with the help of only single coil. Okay, so and we represent the reactances of each. Okay, so let's come here and draw it. Here we are having generator G1. We will be removing this resistance, so we will be connecting G1 with this reactance only, right? So let's see what is the reactance value we are having for G1 here. See, and we are connecting it with this reactance. We will mention the value of reactance of G1, per unit value of G1's reactance here. So what was the per unit value of G1's reactance? 0.3967. So we are mentioning 0.3967 here. After that, what we will do? We will take the transformer which was connected. See here, what we had connected. We had a transformer T1 connected here. See, so we will be taking the transformer T1 and we will connect it. So what here, this coil or this reactance value is representing transformer T1. So what was the transformer T1's per unit reactance value? Come here and see. The per unit reactance value of transformer T1 is 0.4187, right? So we will mention 0.4187 here. See, 0.4187 here. Then what did we had in between the transformer T1 and transformer T2? See, transformer T1 and transformer T2, between them we are having a transmission line. Okay, so here we will not present transmission line with the pi model. We will instead represent it with a simple reactance or inductance, and we will mention the value of per unit. We will mention the per unit value of the reactance of my transmission line over here. So here we mentioned we represent my transmission line with the help of this reactance, and we will put the per unit value of the reactance of my transmission line over here. So per unit reactance of transmission line, what it was? It was 0.5647. See, 0.5647. So we will mention 0.5647 over here. See, 0.5647. After transmission line, what did we had? We had transformer T2. Okay, transformer T2 we had connected over here. So here again we will take transformer T2 again, and we will represent it with simple coil or inductance or reactance, and again we will put the per unit value of transformer T2's reactance. So what is the per unit reactance of transformer T2? We are having 0.4408, so we are putting 0.4408 over here. Then simultaneously, what did we had? We had two generators connected in parallel. Where did it go? Here. See, we have two generators connected in parallel, generator G2 and generator G3. So again we will put a generator G2 and G3. Remember, in the reactance diagram we represent generators as the voltage sources, right? So we will write E2 and E2 here, E2 and E3 here for generator G2 and G3, and we will represent its reactance in the similar fashion we represented the other reactances, and we will again write up the values of the reactance of both the generators with its within its reactor or reactance. Okay, so see here, we for generator G2, what did we do? What did the per unit reactance value of generator G2 was? It was 0.9365. So we are mentioning 0.9365 here, and the per unit reactance value for generator G3 was 0.437. So we are mentioning 0.437 over here. Okay, so this is your complete reactance diagram of the power system which you have just seen, the power system which we have represented with the help of this single line diagram. Okay, so I hope you guys are all clear about the per unit impedance diagram of power system. How do we represent the per unit impedance diagram of power system? Even though we have completed it quite quickly, if you have any doubts, any queries related to it, or if you want to know more about it, you can feel free to mention your doubts or anything else in the comment box. You can also give the feedback if you think the lecture is going too quick, too slow, or if there are some things which are missing in the value. If you think some addition could be good in the lecture, so please you can give all the feedbacks. All feedbacks are welcome. In the next class we will be seeing in detail about how do power factor how we can uh, calculate how we can compensate power factor. So we will be seeing power factor correction value correction methods as well. So I will be seeing you in the next lecture. uh, if you have any queries, any doubts, you can mention in the comment section below. So for till next time, please take care and thank you for listening. Goodbye.